Hello, I'm Nobby. Welcome to my workshop. I think we're up to about part 16 now of the PM Research engine build. In the previous video I'd showed drilling the other end of the cylinder here to fit the end cap that end, and this is just the, if you like, the blanking off end cap on the other end of the cylinder. And I just thought I'd show you how I've lined up to drill the 4 holes. I set this up on the back of the engine frame first so that I could get the holes here sort of level, or nice and level with the cylinder itself. I've got this at a bit of an angle here so that I've got good contact with the cylinder onto the parallels mounted in the vise here. So what I did, once I'd got this set up and levelled up, I made some marks through the 4 holes here to just put little witness marks on the back of the cylinder. And I've also put some, just at the moment, just some sort of Sharpie marks on here to show which is actually the top of the cylinder and the end cap here, so that this will always line up in exactly the same place every time. What I'm going to do later is put some little pop marks on the back here so that I always get the cylinder cap in the correct position. So what I did first was, without the end cap on, was to line up with my usual method of using a little pointer to line up on the cylinder onto that little witness point, and then drilled and tapped the hole. Then I put the cylinder cap back on and put a 5BA screw in, and was able to line up this hole using you can see that, using an 1/8 of an inch drill into the hole to line it up perfectly. Then I could take the screw out the cylinder cap off, and then line up the spot drill to make sure I was in exactly the right position there, and then drill and tap that hole. And I did exactly the same with this one here. So I've done 3 of them already, and I've set up now just to do the final hole. So everything is lined up, and I say I've got the 1/8 of an inch drill in here, so I can bring that down, and I lined it up so that would enter the hole perfectly there. So all I actually move that very slightly. That's better. So all I have to do now is remove these screws, take the cylinder cap off, and then drill and tap that hole, and I'll get all of these sort of lined up nicely. So bear with me just for a moment. Now obviously when you're doing this, you've got to make sure that you keep all the drills and everything in order, to make sure you don't drill the hole the wrong size. So once I've lined this up with the 1/8 inch drill, I keep that right out of the way so I don't mistakenly pick that one up and drill the hole the wrong size. So I'm just going to put the little spot drill in here. And now the tapping drill. I'm not drilling these any particular depth, just that it sort of feels right, because the little screws I'm using will obviously be cut to length to do this. There'll probably need to be, these actually are from another part of the engine, but these won't need to be too long because they're only going through the thickness of the cap here. So let's now in with the tap. Just start this off with the tap in the drill chuck, just to get it started and positioned nicely. And I can release that from the chuck. These are being tapped 5BA. Obviously taking great care with this. Very gently does it. This is a second tap I'm using here, and then I'll go in with a bottom in tap. Just bearing in mind I'm tapping into a blind hole here, so this is, in these cases, got to be very, very cautious. And as soon as I feel any resistance at all on the tap, I'll stop. Take that one out. Blow out, and I'll go in with the bottom in tap now. Again, just taking this one in until I feel some resistance, which I am there. One comes out. So I've got all the 4 holes. Drilled and tapped now, and make sure I put the cylinder cap on in the right position. And just whoops. And then we'll do a test fit. So there we are. That's. I wasn't going to bother to show this. I was just going to get on with the next and final part. But I thought, well, let's just show you how I've done that. I'm sure this is not a unique way of lining the holes up, but rather than set up against those little witness marks all the way around and there be an error, I think using the little drill here to find that whole position was probably a good way of doing it, to make sure I get them all sort of perfectly in alignment. Right, so I'll move on now to the next part. I'm going to machine the piston valve. that's going to be quite an interesting thing to do. I don't think a terribly difficult thing to do, but it's just getting the grooves in the piston valve in exactly the right position, because that will control the airflow through to the cylinder. So join me in a bit at the lathe, and we'll get that part made. There's basically only one part left to make on the PM Research engine build now, and that's the this part, the piston valve. This will give you the sort of timing of the engine itself. The material needs to be a 1/4 of an inch diameter. They do give you a piece of brass in the kit, but this is oversized, which obviously means it's meant to be machined down for a nice fit in the bore that takes the piston valve. But I looked among the materials I've already got, and I actually have some 1/4 inch brass bar already, and I've tried this in the bore, and it is a really good fit. It's a nice sliding fit, which is what it should be. There's not a huge amount of machining to do in this, but what machining you have got to do obviously needs to be quite accurate. The overall length of this is just a fraction over an inch long, and it has machined into it 2 little grooves here, and this controls the airflow into the engine and the exhaust. In addition to that, there's 2 holes drilled into it, one in this end here, and that takes the end of the eccentric rod. So you have this is the eccentric, and on the end of the eccentric you've got this connecting rod. This rod is threaded at both ends with little locking nuts at each end, and on this end there's the coupler, which goes onto the thread here, and there's a little projection here which will go into this hole here, and there'll be a hole drilled through here and through the coupler to lock these 2 parts into position, and the thread on here will enable you to set the correct distance to give the eccentric rod here the right amount of throw to move the piston valve in and out of the bore. In the other end there's another hole drilled into here, down to this point here, and there'll be another little hole drilled into here as well. So this will allow air to escape through this hole and through this hole here out to the exhaust point at the other end of the piston valve bore. So obviously what I'll do is set this up in the lathe. Obviously it will be this way around in the lathe chuck, so that I can face off the end here, drill the necessary hole. Obviously these holes need to be drilled to quite a precise depth, so that they don't run into one another, so that they give you a depth here and a depth here. And I've got a new tool for the workshop which is going to help me measure this drill depth very accurately indeed. So once that's faced off, that's drilled, I can mark out the various positions here and then precisely machine in, probably with a nice sharp cut-off tool, these little grooves in here. Obviously with this one particularly, great care has got to be taken to machine this groove at the right depth, otherwise you'll run into the hole the hole in here. So there's obviously not a great deal of thickness in the wall of this here, so I've got to be very, very careful how I machine that. So I'm going to have to rely on the micrometer dial on the cross slide to enable me to do that. So next thing is I'll set this up in the lathe, and I sort of take you through the process of doing it. Once that's done, I can just then part this off to length, and that will be that part completed. The two holes here and the hole in the coupler, obviously those I'll do in the milling machine. These little holes are quite small. It's a number 52 drill for these, so they're very, very small holes indeed. But anyway, let's move on and get that part machined. At that point I can complete the assembly of the engine and see whether I can actually get it running. Okay, well, I've got the piece of 1/4 inch brass rod mounted up in the lathe chuck. I have already faced the end of this off because there was quite a bit to face off, because it still had a sort of a bit of a hole in there from a previous job. So I'm just going to use a centre drill here just to mark this out, ready for drilling this side, which will be drilled with a 5/32 drill. So we'll do that first. Okay, that will give us the start for the drill. Now move that out the way. So the next job's going to be drilling the hole in here to an accurate depth. And I'll show you the tool I've got now in the workshop to sort of help me do this much easier. So bear with me just a moment and I'll show you this particular tool. Okay, I'm going handheld to show you this. What I have now is a tailstock DRO. This one is supplied by Lin Tools, and this particular one is made specifically for the Myford lathe tailstock for the ML7R, which is the lathe I have, or the Super 7. This can be fitted to the tailstock and removed very simply, and it's not attached by drilling any holes in the tailstock at all. This plate here is attached to this end of the tailstock, and it has 3 little magnets in here to hold it on. If you like, the sort of working end of the DRO, and then the other part here, this part here, is attached to the end of the quill, and you've got a little locking knob to lock that in place. The DRO part works exactly the way all other DROs work on these. It's like a sort of a digital caliper, basically. You've got a sort of simple on-off switch, 0, and measurements can be made either in inches or millimeters. So I've got it set for inches at the moment. It's millimeters, and the inches I've used because the calibration I'm working to on this model is all in inches. So that can be sort of set against the workpiece with the drilling position in the chuck here, then zeroed, and then you simply just wind the quill out in the normal way until you reach the length. So this is going to give a very, very accurate measurement rather than putting Sharpie marks on the drill or bits of insulating tape or things like that. So this will give a much more accurate means of setting this up. So you can see perhaps a slightly better, if we move that right out, a slightly better view of it. So you've got this part here which just attaches to the end, or the front rather, of the tailstock. There's behind here there's 3 of the sort of high strength magnets, and here this part is a clamp system under here which clamps to the end of the quill. I mean, the quill on the Myford is calibrated here. It's calibrated in 1/8 measurements, which gives you quite accurate measurements anyway, but this is going to take measurements to an entirely different level basically. I mentioned in I think a previous video that I was looking for a keyless, a small, very small keyless chuck. And a viewer to my channel very kindly sent me this. This is a very high precision rotor grip chuck, and this has a drill range from 0 to 1/4 inch. That's 0 to 6.5 millimeters, and it's on a JT1 fitting. So this is, I've got an MT2 taper attachment for this. So this is going to be so much simpler for me to switch over drills than sort of fumbling around with chuck keys, which I'm, to be honest, with the weakness of my hands now, I'm finding sort of a bit difficult to do. So these 2 new items in the workshop now are going to make life very much easier for me now. But anyway, I thought I'd share that with you. The company that make these, I understand it is a British company that produce these, and they make them with specific fittings for all sorts of different brands of lathe, including some American lathes like South Bend and so forth. So almost any lathe you've got, there will be one of these available for it. And if I remember rightly, they say that if the lathe you have isn't listed by them, to contact them, and I presume they could then make one up for the lathe you have. So I assume this digital caliper is a fairly standard item. The other parts here I assume are 3D printed. They sort of look, this is probably how they're made, but it's beautifully constructed. This is very sort of professionally made items, so I'm very, very pleased to have this. This is going to make life very much easier for me, and this can be removed from here very, very easily. So if I'm putting any other tooling in the quill, centres or life centres or anything else, I can just pull this off very, very easily. I am having to adapt some of the tools I've got because you're adding these 2 parts together, this sort of extra thickness here. Some of the tooling I have doesn't eject easily. So what I've done with I've got these tools that I made up, a variety of these with different size centres in them. What I've done on the end is I've simply drilled and tapped the end and put a little screw in here that I can adjust to the whatever length. So that will go into it will enter into the quill a little bit further. So the little screw on the end will help items like this eject, and I've got to do I think similar things for some of the other tooling that I've got, just to make them eject, so that if I'm working sort of fairly quickly, I've got to keep taking the the DRO off the tailstock all the time. But there we are. Let's get on with the job now. Right, well, as I mentioned, I've got to drill this hole here with a 5 30-second drill, and it has to be drilled a 1/4 of an inch deep. That's 250 thousandths of an inch. What I am doing, was suggested to me that I must do with drilling into brass, is to make a small adjustment to the cutting edge of the drill itself, by just running a stone along these surfaces here, just to break that sharp edge so that the drill doesn't grab, which I'm hoping that will do the job. I've got this little tiny stone here, so I've done that to this one, and what I'll have to do is keep the drills that I've got specifically for brass on one side, although I understand that in drilling other materials it doesn't really make a difference, that they will still work. But what I'll probably do is have some drills in particular sizes dedicated for that job only. Let's put that drill in the chuck. So what I can do is bring the drill up to that hole there, and then lock that in place. I can zero the DRO. Let's just run that out and run that in. So that's setting quite nicely. So I can run that out, and then I can use the readout here to give me the correct depth now. Getting there. Yeah, exactly 250 thousandths. So hopefully that's going to be okay. I'm going to wind that back without losing my readings, and take the little coupler off and see where that yeah, that goes in fine. Obviously the hole is quite a bit larger than the where the coupling goes in, but I guess that's to allow you plenty of adjustment there. I assume that's what happens. We'll soon find out. Anyway, so that's that little bit done. So now I think what I can do is bring the brass piece out and then mark out the various positions that I need for the little grooves. That's I guess is going to be the next job to do. Okay, well, I've set this up now to machine the 2 grooves. I've marked it, I've put some blue on here, so I've marked it out to this length, which is the overall length of the part, which is 1 inch and 63 thousandths long. There's one groove here which is 125 thousandths wide, 1/8 of an inch, and this one here is a 1/4 of an inch wide, 250 thousandths of an inch, and I've got to machine these grooves in. I had to calculate this because it doesn't give you the actual dimension on the plan, but it does tell you what you end up with. So taking that measurement away from the 1/4 inch diameter, you've got to cut these grooves into 62 thousandths of an inch. So I've set the I'm going to use a nice sort of sharp parting off tool. So I've moved the parting off tool against the material so that I can zero out the micrometer wheel on the cross slide, and then machine into these parts. So this obviously need a number of sort of, or both will need a number of cuts to sort of join them up. So these are the positions here for that one and for this one here. So obviously I've got to be very careful how I do this, because once this is all done, I've got to part this off, turn it round in the chuck, and then drill in this end for the exhaust port. I've put a revolving centre in here to support it as well, because there's a fair amount of stick out here, so I don't want the parting tool to cause this part to move in the chuck. So I'll get this all set up and bring you back while machine these parts out. Just hope it goes really well. Well, that's one done. Now we'll line up for the next one. Obviously running the lathe a lot slower as well, because it's the same as if you were parting off. I'm having to sort of very carefully watch the micrometer dial as well while I'm doing this. well, hopefully that's got it. And I have to sort of very gently deburr each little edge here, just to make sure that there's no burrs raised, because that obviously would stop this going through the bore in the cylinder. But I mean, hopefully I've got that now. I've got a fairly fine file here, so I'll just very lightly try and deburr those bits as well. It feels okay, so I think hopefully we've got that now. So the last remaining thing will be to part this off very carefully, and then drill the hole in the other end. So I'll bring you back for that bit. Okay, I'm ready to part this off now. I did take some measurements of these, because obviously the measurement that I said is got to be 62 thousandths teeth. Obviously that's it's only on the micrometer scale, it's only half that, it's 31 thousandths. I took some measurements of these. They were slightly out, so I've taken just a tiny amount more to get it as near as I can to the absolute diameter of these inner parts here. So I'm ready to part this off now. So I've got everything sort of set up, and cut that off. Just allow fraction oversize, so that I've got just a tiny bit just to face off the end of that as well. Whoops. I'm just going to take the tailstock out the way so that it doesn't grab the part as it comes off, and I'll try and catch the part so it doesn't go flying. There we are. So that's our little part, and I've just got the tiniest bit left just to get rid of that little nub there, and just face that off, ready to drill into that side next. Final operation now. I've turned the part round in the chuck, and I just faced the end off, and I've just centre drilled it there. Didn't bother to show all that because that's quite straightforward. So now I've got a 7/64 drill in here, and I've got to drill into this 5/8 of an inch deep, which is 0.625. So I've got that set up there and zeroed out the tailstock DRO, so hopefully I can get a nice sort of accurate depth with that drill. And of course this hole will match up with one of the cross drilled holes that I'll do later. So let's have a go with this. nearly on depth. 6.2, 6.25. Here we are. So having that DRO on there has made such a difference to everything, you know, being able to drill very accurately, very easily now. Something I've sort of learned from the past is when you're drilling in, I know these are only very, very small drills here, tiny drill, but drilling with bigger drills, if you've not got the workpiece securely gripped in the chuck, is the danger of pushing the part into the chuck. So you've got to be pretty careful, really. Take it very, very easy. Not I guess so much of a problem with a drill of this size, but there we are. So that's basically finished that part. So off camera I'll just make sure everything is deburred nicely, and looking through the chuck there, obviously, I mean, I did hold the drill up against those little grooves in there, and the drill obviously is a lot smaller, so there was no danger of me drilling into any of those little grooves in there. So basically that's it for the moment. So I may bring you back for doing the cross drilling, not sure, but if not, that's quite straightforward. I may just do that off camera, but towards the end of the video I hope to bring you back for fingers crossed getting this engine running. So that's it just for the moment then. Well, the last part I made was this part. You can't see all of it here. This is the piston valve, and that will control the airflow and exhaust to the cylinder. You see here, if I move this round, you've got two little grub screws in here. These block these holes up, but what you do is you remove these so that you can look through the two holes to check the position of the grooves in the piston valve. So the plans for this don't give you a lot of instruction really on how to set this up. All they give you is a tiny illustration showing you the correct position for the piston, and that is with the piston. You see this part, the crosshead moving across here. That's with the piston at the far end of the cylinder, and in that position you need the two holes here to be blocked. So the slots that you machine into the piston valve are sort of either side of these two holes. Once you've got that into position, the eccentric can be locked into position, put on here onto the shaft, and the connecting rod between the eccentric and the piston valve here, you've got the little part here that drops into the end of the piston. It's quite a loose fit, so it allows for, and obviously you don't want it to be very tight. You want sort of some adjustment available to it, and you have to bend this connecting rod so that it lines up, because obviously the eccentric doesn't line up with the bore of the for the piston valve at all. So you've got to I made a sort of a drawing that I could line this up on, but I needed to make a few adjustments to get it in the correct position, and then you can lock both ends with the little nuts here. One end of this I had to cut on this end a little bit of the thread off, because the thread actually was a bit too long, but once that's adjusted, that's fine. So that basically is it. It took me a sort of a while to sort of finally set this up and assemble it all. I had to almost completely dismantle it to get this to line up, because you thread this part into the coupling here for the piston valve, so you've got to take all this apart to be able to thread this end in as well. So you've got to sort of think this through pretty carefully. I've got everything set now. Everything's been oiled up. On the sort of slideways down in here, I've used basically some oil that I use on the Myford lathe. It's used on the bed of the lathe. I think this was quite a good sort of slippery oil, if you like, basically. And everything else I've just used a sort of very light oil. I've made some little oilers here to help oil the shaft. There's an oil hold here, and also here. Perhaps later on I'll make some little oilers to drop into here as well, but I'll sort of do that a bit later on. You'll probably notice that the tops over the crosshead here are loose. Now I found that when I'd made this everything to specification, including the little spacers under here, were all made to the correct size. But what I found was, I think that by screwing these down very tightly, I think it was going to pinch the crosshead a bit too much. I think it needs a little bit of sort of free movement in here. So I've just tightened these down very, very lightly. But what I'm going to do is try and find some tiny spacers that go on top of these little spacers here, just to raise that up, because I'd like to have these down quite tightly, but I think I need to have a little bit more of a gap here than is a sort of allowed in the plans itself. But at the moment, with these a little bit loose, I don't think that's really going to matter too much. So that's sort of basically it. The only things I guess left possibly to do is whether I decide to paint the base or not. The base is obviously the base here is cast iron, and it was painted with a sort of an undercoat. So to paint that, obviously I've got to dismantle everything to do that. So whether I do that, I'm not sure. But what I probably will do is paint the spokes of the flywheel, only the spokes basically, and I'll probably paint those red, because I think spokes on these engines look very, very nice in red colour. So that may be the only thing I do for the time being, and then perhaps sometime later on dismantle the base and paint that as well, and also make a wooden base to stand it on as well. I like to do that with my engines. You notice also that it's got oil everywhere, and I've very, very freely oiled the whole engine, because I want to keep running this and actually run it in. So I know it probably takes quite a while for this to run in itself. In the end, I didn't leave the piston rings in. I found with the piston rings the piston was a little bit on the tight side. I might try the piston rings in again later, but this isn't being run on, is probably never going to be run on steam, so not having the piston rings in I don't think will be a problem. In fact, the grooves that would take the piston rings has given it quite nice oil rings as well, oil positions as well. And I've had that on some of my other engines, just grooves in the piston to allow oil to run sort of quite freely. But let's see if I can actually get it to run again. I have had it running, obviously, because to sort of test everything out. So here goes. I mean, it does actually run quite nicely, and it's quite a nice sound to it as well. You're going to have to take my word for it, but it did run the first time. I was absolutely delighted that it did. So the worry was actually getting the timing of the engine, basically, but I think just following the illustration on the plans really was all it needed. Really, that's basically all it needed. It needed to get the engine running. I'd watched a video from a long time ago, actually, from Keith Appleton, who had one of these engines sent to him to I think to sort of improve its running, and he hadn't built it himself, but he dismantled the engine and made some adjustments to it and then rebuilt it, and he played around for ages with the timing to get it run nicely. I did mess around with this for a while before I ran it, just to make sure that I could see the correct positions in here for the piston valve, and well, that was the proof of the pudding, is it did run first time, so I'm absolutely delighted. Let's give it another run. And the nice thing is that it actually starts itself. When I first ran it, I just had to spin the flywheel, but this does seem to have the right momentum to get it running itself. Let's see if it'll do it again. I'm trying to adjust. I'm running this, see, through an air hose here to the air gun on my workshop compressor. But this is how I like to run my engines. I like to run them nice and slow, so you can see all the movements, and you can see the crosshead covers here moving. I don't think that's a particular worry, but as you can see that there is some movement here, but I'm going to try and adjust that with some little spaces underneath. I think somewhere I've got some tiny brass washers that I might be able to insert here so that I can clamp these down tightly. But I don't know if you agree, but I do think running these engines slow is much more enjoyable than running them fast. I like to be able to see all the actions of the cam and the eccentric and the little piston running in and the crosshead and everything else. So there we are. Very delighted that it's running okay. I started this build about 3 months ago, sort of on and off, and showed various videos along the way over the last 3 months. I don't know how many hours I've put into this. I don't really want to think about that. It's probably the longest build on any engine I've made up to now, actually. So there we are. So we thank you very much, everyone that's watched my video series on this, for sticking with me and following along on the build. And again, it's a delight to me that this runs nicely. Anyway, well, that's it from me. I'm taking a bit of a break from engine building or engines like this for the moment. I have, as I mentioned in an earlier video, got another engine project that I can build later in the year, the Stewart 10V engine. But I want a bit of a break before I start with that, because I'm sort of waiting for some slightly nicer weather to come along, so I can spend a little bit more time comfortably in the workshop. It's not too bad today. It's about 8 degrees in the workshop at the moment, 8 degrees C. So it's not too bad at all, really. So there we are. Thanks once again for coming into the workshop with me, and I'll see you in the next one. Bye for now. Just a postscript to the video. I mentioned that I was going to try and find some washers to go under these crosshead caps, so that I could tighten these little bolts right down so that these were not moving around while the engine was running. But I did manage to find some very, very thin washers. They're about 20 thousandths of an inch, and I've put them under each of these positions underneath the caps, and I've tightened them down, and there's no movement in them now. Worry before was that if I tighten these down, it would pinch the crosshead and stop it from running smoothly. But with these in place, it does seem to run okay. Let's just give it another try. Yeah, so it is running without any problems at all. So that sort of really makes a much better job of it, I think. So there we are. So it is goodbye now until the next one. Cheers.